When you purchase SBI Valvetrain components, that blue and yellow box represents 40 years of industry knowledge, R&D, quality that exceeds OEM standards, and outstanding customer service, as well as a dedicated team, ready to help no matter your application needs. That's how SBI keeps engines humming.
Alrighty, here's a little sample of just some of the kind of stuff that we have to do sometimes. And so this is an existing customer, and of how things just aren't, they're never just put in the machine, hit a button, and it just machines it. That's just not the way it works. So this head was broken, and customer sent it over to a guy to have welded up, and they do a fantastic job of welding. This thing goes all the way underneath that whole area right there. I mean, far superior to my welding, far superior. I don't even know how he welds like this, but this whole area, which resurfacing, you know, the deck surface obviously is no big deal. Intake surface, exhaust surface, that's no big deal because it goes all the way out to here. But that spark plug hole is a big deal. I just don't use a hand drill and, you know, just hold it on the right angle and drill through there. I mean, that's not the way you do it. I also just can't, I don't have a fixture plate for a small block Ford. I don't have all the CAD for a small block Ford for spark plug hole location. So just throwing it over there in the Centroid that's probably like a $3,000 deal just to drill a hole in the spark plug. All things said and done with time, fixture plates, figuring everything all out. It's just a huge deal for something I don't normally do. If it was on my SML or SMX billet heads, yeah, we can do that. That's not a problem. But this is not easy. So what do you normally do? Here we are. Now, I don't have a really good rollover fixture for cylinder heads right now because I have all the Rottler over there, the Centroid, all those kind of things. So I don't really have a designated real rollover fixture. To use the real good rollover fixture here, I don't want to take it out of the machine because we already set up doing cylinder heads, and that is I don't know why that head's in backwards. I gotta talk to Cody about that. But that machine there has to locate on an existing hole. There is no existing hole because the spark plug hole is welded shut. Okay, like I said, fantastic welding. I wish I could weld like, if I could weld like that, I probably wouldn't build engines, to tell you the truth. But that is, I need to come in here and do a quick down and dirty setup. So I roll the cylinder head over, clamp it down so it's good and solid. It's somewhat close to an angle of where I think it's going to be. So I eyeball it this way, and then we turn the cylinder, or turn the head of the Bridgeport sideways, and then I need to indicate in on an existing spark plug hole, like right there, a good spark plug hole. The head is square, so if I indicate in on this spark plug hole, I can go over bore spacing to this one, go over bore spacing to this one, drill a hole even though there's no pilot hole, and machine the flat and make everything all happen. The other problem is I can't get into this hole and indicate the surface real well because it's all up, and you know, the indicator won't fit in here. It just doesn't do that. There probably is some really super small indicator that I could probably get in there and do it with, but the easier way to do it is I come over here to the lathe and I'm going to build a piece that goes into the spark plug hole tight, sits on the seat where the spark plug sits, and then indicate off of the top of this little riser. So I'm going to machine this thing up and I'll show you exactly how this is all going to work. So I make the small part that's going into the spark plug hole. I would thread this, but I don't have a die. I have taps, but I don't have a die this size. So I'm making it the inside diameter of the thread pitch. So it'll go in there, it'll locate nicely, sit on there, and then I indicate in on this top right here. Now what I'm doing right here is I am machining this diameter to fit in the spark plug pocket. And that'll do right there. Get rid of the trim. This is a non-critical dimension. Then we come in here and face this edge, so I have a really nice flat surface. Then I'm going to set up a drill and come in here and drill that hole so I can then center off the center line of the spark plug. So this is the flat out here is to get the angles, and then I'll drill a hole in here to do the center line. That's enough for me to machine. Go in here and I'll knock the burr off. All right, now take this piece out. We'll go deburr this real quick. This has got a nasty burr right there. And this is the area that it needs to sit on. Actually, I think I'll just put it in here and reface it, knock that burr off. There we go. Knock the burr off. Got a nice piece here. Still has a little burr here. I'll go hit this on the deburr wheel and get that off. And then I'll show you how this goes into the cylinder head.
Engine Quest, your home for new OE type replacement and performance engine parts and cores. For our full line of products, visit enginequest.com or call 1-800-426-8771. Engine Quest, the name you trust for engine parts, cores, and recycling.
All right, now I just take this, my little spark plug hole angle simulator thingy, whatever you want to call it. And this fits in very nice. Goes in, sits perfectly flat on the seat. Is a nice little indicator piece for that hole. Now, absolute dead on perfect within a tenth of a thousandth? Absolutely not. Within a few thousandths? Absolutely, not a problem. After this amount of welding, this amount of repair to save this cylinder head, and did the customer, you know, I told him how much it was going to cost to do all this. I don't know how good a price he got on a welding, but apparently it's still worthwhile to do. Can't get the cylinder heads right now. Time frame. Got to make stuff happen, so we're making stuff happen for him. And after we do this spark plug hole, I'll show you, how we got to resurface, how we got to repair the rest of this thing. But now we'll just go in here and I'll start working on the indicating of that little puck right there. So you got to rough eyeball this in all first. Turning the head here is a series of complex angles that keeps on changing heights and everything. So keep moving that down. And then all I'm still doing here is finding this angle, both angles. Okay, I am getting closer. It's touching more on this side than over here. I'll show you how this all centers up here in a second. It's getting close. So that's within 5, 10, within 15 thousandths on angle. That's about 1 degree. 10, and then we'll go over and we'll do this dimension. This dimension, right now we're doing X. We'll do Y. And that is within 3 thousandths, which is probably 3 thousandths over an inch. I can figure out the exact math, but that's probably I think it's 17 thousandths per inch is 1 degree. So one degree is 17 thousandths rise, 17.5 thousandths rise in 1 inch. So that's half. So that's like 1/4 of a degree different. Now we need to come in here and do the X. So I've now tightened up the head, so it's no longer rotating here, and we'll give it a little bit extra here in a second too, just to make sure get it even closer. But I need to tighten that one up before I can do the Y. Now we take this head right here, we've tipped it this direction. Now I have to tip it this direction, and I couldn't, or vice versa, I might have to go this direction. So anyways, spot it this way. That, this is just eyeballed it. I eyeballed this thing, put a shim up there and kind of guessed at it and got it within 25. So I got it within 2 degrees basically right there by just guessing at it. So now I'll have to move this head and do that. Let's see, so it is low there. Low. So that means the head needs to tip back this way. Overcomplicated. Alrighty, so I got the whole thing within just a couple thousandths, which would be tenths of a degree all the way around. So I'm pretty happy with that. So I have the angles all figured out for the spark plug. Okay, so the spark plug is going to go in on the correct angle. Now I come in here and I'm going to indicate in on the small hole that I drilled in the very center of that. Right there. And then that will give me the exact location of where that spark plug hole is, which will give me the exact location by 400, which is the bore spacing from here over to the next one. So from here or this one. All right, so now that goes up. Everything's all locked in the head. I was within, yep, 1.5 degrees according to the scale here. So if you look at the scale, I was within 1.5 degrees of zero. It was on zero, basically. And then here we had to turn this whole thing to, where's it at? The angle up here. Where's the freaking angle up here? It's got to be about 40 or so. Well, anyways, let's go back down to indicating in this hole. All right. Now, actually, indicating in the hole is actually easier to do. That's that is, it actually just, the indicator actually just picks up the roughness of the hole. You just kind of see it flipping around. But anyways, that thing is within about, well, actually I think it's dead nuts. I think it's perfect. It just has a little hole deviation in there. So now this thing is the drill, everything, the angle is correct, the drill angle is correct, and the hole location is correct. So now I can change the I can change the chuck in this. This is actually going to be a little bit tricky here because there is one little issue, which is I got to make sure that my chuck and my drill are the same length, because you cannot raise the knee. So I can't ever change the cylinder head height because that changes the location. I can only change this angle. So if this head comes up, so imagine you're on this angle, if this head comes up right here, the angle, the cylinder head goes root like this, no longer lines up. This hole, the drill has to drill this direction. That's why these 5-axis machines like that are so insanely cool, because they're drilling on multiple axes on the same time, which is just insane. So anyways, I'm going to put my drill chuck in here, drill this hole, and tap it. We'll come right back. All right, got everything all re-indicated in. Put my drill in there. It actually moved it off about 2 inches, and it did move it in because I had compound angle here. So I have an angle here, and I have an angle here. When you move the cylinder head up, the part up into that angle, it moves it both directions, X and Y. Ugh, it's so freaking overly complicated. But anyways, we're getting ready. I'm just gonna spot this in, and we will proceed on. Oh, sorry. We're still in the test hole, the setup hole. I'm all zeroed. Now I will move this over 4380. Or 380. Bada bing, bada boom. All right, and that has now spot faced the spark plug hole in the correct location. Alright, there is tap hole size right there. And now I'm going to work on such a mofo because the tap, let me go grab the tap. So what I'll be doing here is I can't change my whole setup again. So the tap is not as long as the drill, so I'm going to have to got enough travel in the machine to get it started, so then I can finish off by hand. Just got to get it started correctly, and then we're good from there. Alright, so got it started about almost a half an inch right there. Now I don't want to change or tear down any of my setup, so I need to go get my tap stuff and just run this through the rest of the way with oil and my tap handle. Now while I'm at it, I'll just chase these other holes just to make sure they're nice and good. Okay, so now I've come in here, never changed my setup. Sorry about Kyle's running a dyno right now. But now you can see in here, I've spot faced it for the spark plug washer to go in there. When he did the welding on it, he didn't weld all the way around that whole portion of the pocket, so it actually left a nice register for it. And so you can now see that pretty well. But that is a nice new clean spark plug hole. So now I have to spot face this head bolt hole to make it flat, because it's not flat obviously. Have to resurface this surface resurface it, the main surface, go in and blend the combustion chamber. But as of right now, so this is just showing how to replace this, to do this spark plug hole. The rest of it's just basic machining, it's not a big deal. I'm into this thing for 4 hours. Okay? Drilling a hole, $400. Because that's what it cost me just to maintain business. So just to give you guys what it is. And so then I got to do the rest of the processes on this thing to help a customer, save them, get them going fast, try to make things happen for people. But that's all this stuff. I'm really just showing you this so you can see how you actually got to do it, to see that it is not you just put this head in the machine and you hit some magic green button and it just fixes it. And it's not some easy thing where you just drill it by hand unless you're hacked. But that thing, this, I just showed you the correct way of doing it with the equipment I have, without just throwing it in a CNC machine. I explained why I can't do it in a CNC, why I can't do it in a 5-axis machine, because by the time I didn't make this head, by the time we do the whole thing, I'd have 3 days into it trying to make that happen. So that ain't gonna work. This is the quickest, easiest, best way of doing it for this minute. So we're going to just finish off the rest of this little stuff. You've seen all those kind of things before, but that's how you get things done. I'm Steve Morris. Like, subscribe, share.